Hey guys, today we're going to take a look at 7.4, which are, it's called the sum and difference formulas. And what they are, so if you look down here in this box, you're going to see a bunch of formulas, equations, okay? And what it does is, if you want to know the sine of two angles that are being added together, okay, the sine of A plus B, or the sine of two angles that are being subtracted from each other, or the cosine of those two situations, or the tangent of those two situations. These are formulas that will do that. Now, unfortunately, finding the sine of A plus B is just not as easy as finding the sine of A and the sine of B and adding those together. It doesn't work that way. Okay, so we have these formulas that will do these things. These formulas will be given to you. This isn't something I'm going to expect you to memorize. Okay, there's a lot going on here. But the reason this comes up, if you look at the top here, it says, what is the exact value? Whenever you see exact value, it means do not touch your calculator. There's a different way to find this. Okay? What is the exact value of the cosine of 75? Well, 75 is not on our chart that we use. However, 75 is equal to 30 plus 45. Okay, you can take a 75-degree angle and you can split it into these two angles, both of which are on our chart. So if I wanted to know the cosine of 75, I could take the 75, I can split it into 30 plus 45, and I could find the cosine of 30 plus 45, which means I'm going to use one of these formulas down here. Okay, so the sine formulas. You'll notice the sine of A plus B. It's the sine of the first angle. So A and B, this is actually alpha and beta, but I'm just going to say A and B. Okay, it's the sine of A times, okay, so these two things that are next to each other, that's multiplication. So the sine of A times the cosine of B, so the cosine of whatever this angle is, and then plus, and then it's the cosine of A times the sine of B. Now there's a whole lot of words I just said. However, again, all you have to do is be able to follow this formula and plug things in where they go. Okay, the sine of A minus B looks the same, except it's got a minus right there. In fact, a lot of times these formulas are written together as the sine of A times the cosine of B, and then plus or minus the cosine of A sine of B. Okay, I usually write them separately. All right, the cosine sum and difference formulas. The cosine of two angles that are being added together is simply the cosine of the first angle times the cosine of the second angle, and then it's minus, so notice that the sum formula has a minus in it. That's going to be something you're going to have to pay attention to. Okay, and then it's the sine of A times the sine of B. The subtraction formula, the difference formula, looks exactly the same, except it has an addition in it. And then the two tangent formulas. Now the tangent formulas kind of start off the way you think they should. Okay, the tangent of A plus B starts, first off it's a fraction, and it's the tangent of A plus the tangent of B, and then it's 1 minus the tangent of A times the tangent of B. So these same two values that you got in the numerator are going to be down here in the denominator, except they're going to be multiplying each other instead of adding together. The tangent of A minus B, so an angle minus another angle, it's the tangent of A minus the tangent of B, and then it's 1 plus the tangent of A times the tangent of B. Okay, so those are the formulas, but let me show you what this looks like. Okay, so example A is the cosine of 75. And again, if you've got a chart handy, I've got my chart here. Okay, I'm probably going to need that in a second. All right, so the cosine of 75. So I am going to take that and I'm going to rewrite it as the cosine of 30 plus 45. Okay, I'm taking 75, I'm splitting it into two angles that I do know the values for. So this is my A and this is my B that are going to get plugged into the formulas. So here is the cosine formula. This is the cosine of two angles being added together. So the formula says I'm supposed to take the cosine of the first angle, so the cosine of 30, I'm supposed to multiply that times the cosine of the second angle, so the cosine of 45, minus, and then it's the sine of the first angle times the sine of the second angle. So the sine of 30 times the sine of 45. All right, so now we're here. Now I just need to simplify this. Okay, what is the cosine of 30? Well, the cosine of 30 is radical 3 over 2. Times, what is the cosine of 45? Well, that's radical 2 over 2. Minus sine of 30. Sine of 30 is 1/2. Sine of 45. Sine of 45 is radical 2 over 2. Now simplify. Multiply straight across. Radical 3 times radical 2 is radical 6. 2 times 2 is 4. Minus 1 times radical 2 is radical 2. 2 times 2 is 4. Now, I've got two fractions that are being subtracted. They have common denominators, so I could combine them together. Now, there's not a whole lot of simplifying that you can do on the top, because you have a radical 6 minus a radical 2. Those are not like terms. They're not really going to simplify, but you can get radical 6 minus radical 2 all over that common denominator of 4. And that is the exact answer of the cosine of 75. Look at B. So B says, what is the cosine of 195? Now, for most of you, the trick or the hard part is going to be thinking of this in terms of two angles that add up to that number. And these two numbers that I'm going to split, 195 is not on our chart, they have to either be on our chart or have reference angles that are on our chart. Okay? So I don't just have to use 0, 30, 45, 60, and 90. I could also use angles like 150 that has a reference angle of 30, or 120, or 240, angles that have reference angles that are on our chart. So as long as the angles allow us to use our chart, then those are good values to use. Okay? So 195. I've got to come up with a way of rewriting 195 into two angles that either add or subtract to equal 195. Now, the easiest one that I can think of is now you don't have to write this down because I'm not going to do this. Okay, 150 plus 45. Okay, 150 and 45 would add up to 195. 150, it has a reference angle that's on our chart, and 45 is on our chart. So both of those would work. The reason I'm not going to do that, I just want to show you a different way to do it. Okay, I want to show you, I use the addition formula over here, so I'm going to purposely do this using the subtraction formula for no reason except so that you can see an example that uses the subtraction formula. Okay, that's it. Honestly, between you and me, I would probably use 150 and 45. Okay, that's just the easier ones to use. But I'm going to use 240 minus 45. I just want an example that uses the subtraction formula instead of the addition formula. That's it. Okay, so I'm going to now plug this into this formula. I'm going to take the cosine of 240 times the cosine of 45. And you know what? Plus, if you went ahead and did the 150 and 45, you could do that on your own, and then I guarantee we're going to come up with the same answers. And then what's this going to be? The sine of 240 times the sine of 45. Now, remember, my next job is to simplify all these things. Okay, I'm going to be using my chart and the reference angles for these. Do not forget to use your, all students take calculus. Okay, that angle 240 that I used, that's in quadrant 3. So when I go to simplify down here, when I do the sine of 240, I'm going to be using my chart for 60 degrees, because that's the reference angle for 240. It's 60 past 180. But that actual angle is in quadrant 3. So the cosine of 60 is 1/2, but this is going to be negative 1/2. The cosine of 45, 45 is in quadrant 1, so we're good there. Radical 2 over 2. Plus the sine of 240. Again, 240 is in quadrant 3. The sine of, it would be negative radical 3 over 2. So don't forget the rules we learned in chapter 6. Okay, all of that still applies. So those are the ratios. Now I can multiply these two together. That's going to be negative radical 2 over 4. I can multiply these two together. That's going to be negative radical 6 over 4. And now I can combine these together into one fraction, negative radical 2 minus radical 6 over 4. And that's it. Okay? All right. Now, notice that there's a lot of similarities between these two answers. You're going to see that happen a lot. Okay, there's only so many numbers we're using on our chart, the 1 over 2s, the radical 3 over 2s. Okay, so you're going to see what looks like the same answer. Now, these are not the same answer because on this one, the radical 6 is positive and this one is negative. So you will get, they're different numbers. Okay, just in their simplified exact form, they look very similar to each other. Okay, now, for C and D are both in radians, so these are going to be a little trickier. So again, my goal is I need to think of this. This is 1/12. Okay, now that's a very small fraction, 1/12. Okay, I need to think of that as two numbers that are either being added together or subtracted. Hint, if you have an angle that small, the only way to get there is by taking two numbers and subtracting them from each other. Okay? I need to think of two numbers that will subtract from each other. They have to have common denominator, so they're both going to have 12s in the denominator. You'll notice nothing on our chart has a 12, though. Okay? So what's going to happen is this is going to be two angles with a common denominator of 12 that subtract to give you 1 and will reduce to be on our chart. Okay, so for this one, let me just show you. So the sine of, and I'm going to think of 1/12 as 4/12 minus 3/12. Now, this is not the only way to do this one, but 4/12 minus 3/12 equals 1/12. No argument there. Now, both of these reduce. The 4 and the 12 reduce, giving us pi over, what's 4 and 12 would be 3. The 3 and the 12 reduce, giving us pi over 4. Now, these two angles are on our chart. So now we can do this. So this works. What else could I have done? I could have done 3/12 minus 2/12. I could have done 3/12 minus 2/12 because those both reduce. 3 and 12 gives you pi over 4. 2 and 12 gives you pi over 6. Those are good to go. What could I have not done? Well, 5/12 minus 4/12 because the 5/12 doesn't reduce. It's not going to be anything that's on our chart. 7/12 minus 6/12. Okay, these are all numbers that are 1/12 away from each other. 7/12 minus 6/12. But they don't help us. It's got to be numbers that are going to reduce with our denominator to end up with something on our chart. Okay, so now that we know our two angles, we can use the sine of A minus B formula, where this is our angle A and this is our angle B. So see if you can plug those values in and then simplify down to this answer. So these are the two angles that are getting plugged into the formula. So plug them in, then simplify. Take the sine of the first angle, take the cosine of the second angle using your chart, and then see if you can combine that down and simplify it as far as it'll go. Okay? All right, so this is what you should have got. So we had the sine of pi over 3 minus pi over 4. So this is my alpha and this is my beta, or my angle A and my angle B. So I took the sine of the first angle times the cosine of the second angle minus the cosine of the first angle times the sine of the second angle. So that's the formula. And then I use my chart to simplify. The sine of pi over 3 is radical 3 over 2. Cosine of pi over 4. Cosine of pi over 3. And then the sine of pi over 4. And then I combine these together by multiplying and subtracting. Okay? Example D. So this is a tangent. So now we're going to use the tangent formula. So again, the hardest part for some people is just figuring out how to divide this into two separate angles. Now, instinctively, The number 7, our brain wants to kind of turn that into 3 and 4, which works for us, because if we rewrite this as 3 twelfths plus 4 twelfths, which does add up to 7 twelfths, both of these reduce in a way that helps us out. So 3 pi over 12 reduces to pi over 4, and 4 twelfths reduces to pi over 3. Okay? Now, there's other ways to do it. You could do it with subtraction. There's no other way that I can think of to add. So like if you thought of 7 as 5 and 2, well, yes, 5 and 2 add up to 7, but the 5 twelfths won't reduce and it won't help you. Okay? Thinking of 7 twelfths as 6 plus 1. Again, 6 twelfths works. That'll reduce, but not 1 twelfth. 1 twelfth, you're kind of stuck with it, and that is not something that's on our chart, so it doesn't help us. It has to be split in a way where those two angles are going to reduce to be on our chart. So that works, and now we can plug things into the formula. So that's first. So look at the formula on the top, the tangent of A plus B. So it's the tangent of the first angle, pi over 4, plus the tangent of the second angle, pi over 3, and then it's 1 minus these two multiplied together. Tangent of pi over 4 times the tangent of pi over 3. And this has to be done first. Okay, that's multiplication, so that has to be done first. Now, what are these values? Well, the tangent of pi over 4 is just 1. Okay, so now I'm using my chart. Okay, so I'm using the chart. Tangent of pi over 3. Tangent of pi over 3 is radical 3. So plus radical 3. And then 1 minus those exact same values multiplied together. Well, those values are a 1 and a radical 3. And when you multiply those together, you're just going to get a radical 3. Okay? So that is our answer, except that we have a radical in the denominator, and we're not allowed to have that. Okay? Now, if all we had was a radical 3, that's easy. We would move the radical 3 up, we'd write it without the radical, and we'd be all set. This isn't like that. This is a binomial where one of the parts is a radical. So 1 minus radical 3. Here's how we have to fix this. We're going to multiply 1 minus radical 3 times its conjugate, which is 1 plus radical 3. Okay, that's what we're going to do. We're going to multiply those two things together. Now, how does that help? Well, now you would have to FOIL. This is a binomial times a binomial. So if you FOIL this out, you would get 1 times 1. You would get 1 times radical 3. But then you would get negative radical 3 times 1. So those two are going to cancel each other out. But then you would also get negative radical 3 times positive radical 3, which would be minus plain old 3. So that's not a radical. These two radicals cancel. And so our final denominator is just whatever 1 minus 3 is, which is negative 2. Now, you'll notice I didn't do anything to the top yet. Whatever you do to the bottom, you have to do that exact same thing to the top. So I'm going to have to multiply the top by 1 plus radical 3 as well. Now, these things are not going to cancel. These are two binomials where you're just going to have to FOIL them out. 1 times 1, 1 times radical 3 times 1, and then radical 3 times radical 3 is 3. Combine like terms. The 1 and the 3 would give you a 4. The radical 3 and another radical 3 means I have 2 radical 3's, not radical 6. Okay, I have a radical 3 and another radical 3, so I have 2 of them. And now both of these, now here's another step. Both of these can reduce with that 2 right there. Okay, so think of it like the distributive property. The 4 can be divided by negative 2, which is negative 2. The 2 can be divided by negative 2, which is like a minus 1. So that is the absolute simplified answer of the tangent of 7 pi over 12. And that is how you have to write your final answer. So the tangents are a little tricky because we have fractions, and you're often going to end up with a radical in your fraction. it's going to happen that you're going to have to rationalize that denominator. Okay? Little tip, when you have a tangent and you have to split it into two angles, if you can avoid using pi over 6 or 30 degrees, do so. And there's always a way. You may have to think of it as a subtraction problem instead of an addition problem or something like that. But if you can avoid 30 because of this radical 3 over 3, it's kind of a pain in the butt to use. Okay? So if you can stick with the 45 and the 60, where you're only having to use the 1 and the radical 3, it will make your life easier. Okay? And like I said, there's always a way to avoid it. Sometimes you just got to be clever in how you're splitting up your angle in order to get that. Okay? All right, now on the back, we're going to do the exact same thing. We are still going to find the sine of a plus b, or the tangent of a minus b. We're going to use the exact same formulas, except instead of using our chart, which gives us the same, like similar answers over and over and over, we're going to have a little bit more variety with our answers, because we are going to get our values from triangles. Okay, so here's what's going on. So again, we've done this before, but now we're applying it differently. Find the sine of a plus b given some information about angle A and angle B. Okay, so instead of it coming from a chart, what we're going to do is we're going to say, okay, angle A, the cosine of angle A is 1 over 2. So we know the relationship between the adjacent and the hypotenuse. And we know that this angle A is between negative pi over 2 and 0. So what that means is quadrant 4. Okay? Between negative pi over 2 and 0. So in quadrant 4. Now again, we are allowed to be in quadrant 4 because they're not using inverse notation. So we aren't restricted to just our principal values. That's why they had to tell us exactly where it is. Okay, and wherever they tell you that it's at, that's where you're going to draw your picture. So I'm going to draw angle A in quadrant 4. So this is A. Usually I put a little theta there, but I'm going to put an A because we're going to have a different triangle, which is going to have angle B in it. I know that the adjacent to hypotenuse is 1 to 2. I know my opposite side is going to be negative. Okay, so, and then I'm going to have to use the Pythagorean theorem to figure out what that is. So 4 minus 1 is 3, so this is going to be radical 3. Okay, so that's everything I need to know right now about angle A. I'm going to come over here and draw a picture for angle B. I know that the sine of angle B is 1/3, so that's the opposite, and that's the hypotenuse. I know that angle B is between 0 and pi over 2, so it is in quadrant 1. So I'm going to draw a picture in quadrant 1. This is B. I know that this is 1. This is 3. That's going to be 9 minus 1 is 8. I am not going to write radical 8. I'm going to write 2 radical 2. And now this is everything I could possibly need to know about angle B. So so now that we have our two pictures, now we can answer the question. What is the sine of A plus B? Well, using your formula, it's going to be, and I'm just going to go ahead and write the formula. It's the sine of A times the cosine of B, and then it's plus, and then it's the cosine of A times the sine of B. So now, let's fill in this information from these two pictures. The sine of angle A, here's angle A, negative radical 3 over 2. That is the sine of A. Times the cosine of B. So now we're over here. The cosine of B is 2 radical 2 over 3, adjacent over the hypotenuse. 2 radical 2 over 3. Plus the cosine of A, so now we're back to A, 1 over 2, times the sine of B. The sine of B is 1/3. So exactly the same thing we did before. We're gonna multiply these together. So that's going to give us negative. Radical 3 times radical 2 is going to be a radical 6. You can multiply radicals. So it's going to be 2 radical 6 over, and then 2 times 3 is 6, plus, well, 1/2 times 1/3 is 1/6. And then again, I've got two fractions with common denominators. You're always going to have a common denominator. So I can combine these into one problem. Negative 2 radical 6 plus 1 over 6. Now this is fine. This is a fine answer. Okay, you don't have to change this. A lot of times when we have like a negative plus a positive, we rewrite it as a subtraction. So if you solve that as like on an answer key, that's the same as that. This is just a way that a lot of times books will write things. It's just a little neater with the subtraction instead of that negative sign out front. Okay? All right, so look at the next one. What is the tangent of A minus B given some information about angle A and some information about angle B? Okay, so we're going to draw pictures. We know that angle A is between 0 and pi over 2, so it's in quadrant 1. We know angle B is between negative pi over 2 and 0, so it's in quadrant 4. And now we just need to draw some pictures. So angle A. I know the cosine is radical 5 over 5. Now, I could leave this. So here's my triangle. This is my adjacent, and this is my hypotenuse. So this could be radical 5, and this could be 5. Now, when I go to find this side over here, it would be 25, that squared, minus 5, which would be 20, and then I have to take the square root of 20. But the square root of 20 is, well, radical 20 is 4 times 5. So this is really 4 radical 5. That's what that side would be. Now, there's another thing you could do is we could have unrationalized this. We could have wrote this as 1 over radical 5, which is what this used to be before they fixed it, and we could have wrote it that way. Okay? Either way will get you the same answer. So that's my picture for angle A. So when I get down to the formula, whatever I need to know about angle A, it's right there. Sine, cosine, tangent. Well, the tangent formula only involves tangents, so that'll be right there. Angle B is in quadrant 4. Negative 4 and 5. I'm going to use the Pythagorean theorem. This is a 3, 4, 5 triangle. So that's a 3. All right. So the tangent of A minus B is the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B. So that's going to be the tangent of A. So now we're over here. So 4 radical 5 over radical 5. But that means those are just going to cancel and you're just going to get a 4. That's just a 4. Minus the tangent of B. Okay, so now we're over here. The tangent of B would be negative 4 over 3. Negative 4 over 3. And then 1 plus, so 1 plus. And then these two things multiplied together. Okay, so the tangent of A times the tangent of B. So 4 times negative 4 thirds is going to be negative 16 thirds. That's what that is. Now, there is a lot going on here. Let me show you a little trick. These are complex fractions. I've got a fraction in my numerator, I've got a fraction in my denominator, and then this whole thing is a fraction. I can fix this by multiplying by 3. Everything. 3 over 3. Why is that allowed? Because 3 over 3 is just 1. Okay? But if I multiply every single thing by 3, watch what happens. 3 times 4, that's 12. 3 times negative 4 thirds. The 3 and the 3 will reduce, and I'll just get a negative 4. I don't have a fraction anymore. 3 times 1 is 3. Plus 3 times negative 16 thirds. Again, the 3's cancel, and you get negative 16. That's it. That's our problem now. 12 minus negative 4, which is same as 12 plus 4, so that's 16. 3 plus negative 16, so that's 3 minus 16, that's negative 13. And that's it. That is our answer of the tangent of the angle A minus B. Okay? Now, on the bottom, bottom's going to look different. It's not. It's the exact same as what we just did. what is the cosine of some angle that has a sine value of 2/3, so we're going to call this angle A, plus some angle that has a tangent value of -3/4. That's what the inverse notations mean. It means I have an angle that has this tangent value. But for this one, they're using the inverse symbols, so this does use only the principal values. So they don't have to tell us where the angles are because we know where the angles are. If they're doing the inverse sine of a positive value, this angle has to be in quadrant 1. This is where angle A is. I know the opposite. I know the hypotenuse. 9 minus 4 is 5, so this is radical 5. Now I know the adjacent. Over here, they're telling us that there is an angle that has a tangent value of -3/4, and since tangent is only allowed to be in quadrants 1 and 4, quadrant 4 when it's negative, that's where this angle, which I'm calling angle B, must be. So what do I know? I know the opposite and the adjacent. -3, because we're going down, so that has to be the negative side, over 4. And then the Pythagorean theorem will get me a 5. So there you go. What this problem is really asking is, what is the cosine of A plus B given this information about A and B? So that's what they want us to find. What is the cosine of A plus B? So use the formula. The cosine formula is the cosine of A times the cosine of B. Minus, remember the addition formula has a minus, and it's the sine of A times the sine of B. I'm going to pause this. Go ahead and see if you can plug in the information from those triangles where it goes. All right, and that's what you should have got. There's the cosine of A from the picture. There's the cosine of B. Minus. There's the sine of A. There's the sine of B. Now simplify. Multiply these two fractions together. Radical 5 times 4 is just 4 radical 5. 3 times 5 is 15. Multiply these. Don't cross-reduce here, because if you just multiply straight across, you're going to get a common denominator with this fraction. So just wait until the end. Everything will work out for you. You're always going to get a common denominator, and then you can combine them into one fraction. Okay? Now, the last one I want you to try to do. So it's the cosine of, now if you read this, it would say, what is the cosine of the inverse tangent of 4/3 plus the inverse cosine of 12/13? Which doesn't mean a whole lot. Okay, there's a lot of things I just said. What we're trying to find is the cosine of this angle that happens to have a tangent value of 4/3 plus this angle, so it's a different angle, which happens to have a cosine value of 12/13. So you need to draw two pictures. You need to think about where those pictures are, since both of these are positive. Okay? And then once you have the pictures, use the formula for the cosine of A plus B and plug that information in and see if you can simplify this. Okay? Alright, so that's what you should have came up with. So look at my triangles. Okay, they're both in quadrant 1 because these are both positive, and that's where we're allowed to be if we're using the inverse notation. Okay, we're allowed to be in quadrant 1 where it's positive. And then I went ahead and I rewrote what we're trying to find. We're trying to find the cosine of this angle plus this angle. So the cosine of A plus B. I then wrote the formula. I like to write the formula and then replace each part of the formula with what it equals. The cosine of A is 3/5. The cosine of B is 12/13. So one at a time, I'm just replacing the value, or in the formula with the value that it is. And then I simplified. I multiplied these two fractions together. I multiplied these two fractions together. And then I subtracted, and I got my final answer of 16/65. So take a look at the worksheet. Try some of these on your own. And if you have questions, please let me know.